Hello friends, welcome to the class on control engineering. So in this problem we are going to solve another problem on root locus. So here instead of giving g of s into h of s, they are given the characteristic equation. Okay, so for this we have to find out the root locus. So what we have to do, first we need to find out the g of s into h of s. We know the characteristic equation is equal to 1 plus g of s h of s is equal to 0. So instead of giving the g of s into h of s, they are given the characteristic equation. So I can write this given equation like this: 1 plus what, k s square minus 4s plus 8 divided by s plus 1 s minus 0.5, like this, that is equal to 0. Okay, just by taking the LCM and all. Okay, so therefore what is g of s into h of s? This is open loop transfer function. G of s into h of s is equal to k s square minus 4s plus 8 divided by s plus 1 s minus 0.5. Okay, so I got the g of s into h of s. So now step number 1, to get the general information. Number of poles, that is the denominator term, there are 2. Number of zeros, here also number of zeros is equal to 2. Why? In the numerator the highest degree is 2s to the power of 2, therefore number of zeros is equal to 2. So therefore number of branches will be equal to 2. Okay, what next? End starting point of the branches, it is always going to start from the poles. What are the roots of this? So this will be equal to minus 1 and plus 0.5. okay, minus 1 and plus 0.5. These are the starting points. What are the ending points? So that are the roots of the zeros. So here we have a complex 0. So therefore I am going to find out this formula, minus apply this formula, minus b plus or minus root of b square minus 4ac divided by 2a to find out the roots of this complex pole. So after applying this formula, I found out s is equal to 2 plus 2i and another root is 2 minus 2i. Okay, so these are the starting point, these are the ending point of the branches. Next, what? Step number 2, to draw the to predict the root locus on the real axis. Okay, for that we are going to draw the pole 0 plot like this. So the first root is first root is 0.5, right, somewhere here 0.5 and minus 1, and other root is 2 plus 2i. So 2 plus 2i somewhere here, 2 plus 2i, 2 minus 2i, so 2 minus 2i. So these are the zeros and this is the pole. Okay, so on the real axis we have two roots. So I am going to draw the imaginary axis between two roots. How many roots to the right side? We have a one root, therefore root locus is possible between 0.5 and minus 1. So this is what the prediction. So root locus is possible between 0.5 and minus 1. Okay, step number 3. What is step number 3? To find out the number of asymptotes. So in this case there is no asymptotes, right? Because what is the form? Number of asymptotes is equal to how much? P minus Z. So here number of poles is equal to 2, number of zeros is equal to 2. So therefore, so number of asymptotes is equal to 0. So therefore, no need to find out this So therefore step number 4, that is to find out the centroid, is also not required. This is also not required. So I'm going to find out the step number 5. What is the step number 5? To find out the breakaway points, because here we have root locus between the two poles, so therefore we'll be having a breakaway points. So for that we need a characteristic equation, 1 plus s minus 0.5 plus k s square minus 4s plus 8 is equal to 0. So what is the value of k? Cross multiplication, so this will be minus of s plus 1 s minus 0.5 divided by s square minus 4s plus 8. Okay, so let me take this as equation number 1. So now I am going to differentiate this k with respect to s. So this is in the form of u by v, that is a quotient rule I am going to apply. What is the quotient rule tells? D by dx of u by v is equal to v into du by dx minus u dv by dx divided by v square. I am going to apply the quotient rule. I hope all of you know how to do the differentiation. So just I am going to write the final equation. Okay, after applying the quotient rule and simplifying the above, I am going to arrive at 4.5 s square minus 17s minus 2 is equal to 0. So this is after differentiating and equating to 0 and simplification, I got this one. With the help of calci, I am going to find out the roots of this s, that s is equal to plus 3.89 and s is equal to minus 0.114. As per the prediction, root locus is possible between 0.5 and minus 1. So we have this a plus, therefore this is a invalid. So this is the valid breakaway point that we can clarify by substituting this value in the equation number 1. So after substituting this value in the equation number 1, the k value I found out is plus 0.0642. So therefore this is a positive value. So this is a valid breakaway point. Okay. What is the next step? So this one is over. Finding the breakaway point is over. So next one is to find out the intersection with root locus. That is step number 6, right? Step number 6, intersection of root locus with imaginary axis. For that we need a characteristic equation. So I know s square, just after simplification, what we have, the equation s plus 1 s minus 0.5, that's the equation that has been given, k s square minus 4s plus 8 is equal to 0. So I am going to simplify this. So this can be written as s square plus 0.5s minus 0.5 plus k square minus 4s k plus 8k is equal to 0. Now I am going to group the terms. What are the coefficient of s square? So k plus 1 s square. Okay, s square s square. Next one is coefficient of s, 0.5 minus 4k s. Next one, 8k minus 0.5 is equal to 0. So this is the characteristic equation. Okay, so to find out the intersection of root locus with the imaginary axis, I am going to apply the RH method. What is the highest order here? That is the s to the power of 2, then s to the power of 1, then s to the power of 0. Coefficient of s to the power of 2 is k plus 1. Then this value, that is 8k minus 0.5, then s to the power of 1, that is 0.5 minus 4k, that is equal to 0. Next, to find out this into this, that will be, and minus 0 into this divided by this. So I am going to get 8k minus 0.5. Okay, so after creating the array, that using the RH method, now I need to find out the values of k. So here the main for the system to be stable, the first column must be positive. For this to be positive, so this must be greater than 0. Okay, so now I need to find out the value of k in this and also this. So I am going to consider this value 0.5 minus 4k must be greater than 0, as well as 8k minus 0.5k 0.5 must be greater than 0. So these two terms must be greater than 0. For this, then only we can say the system is stable to find out the k margin. So I am going to equate this equal to 0. So I got k is equal to 0.5 divided by 4, that is equal to 0.125. So for this, k is equal to 0.5 divided by 8, that is equal to 0.0625. See, I got two values of k, right? Now I need to find out the intersection of root locus with the imaginary axis. For that, I am going to consider the auxiliary equation. What is the auxiliary equation? So s to the power of 2 term. So write down the equation by using this. So this can be done as s square k plus 1, then s to the power of 0, that is 1, 8k minus 0.5 is equal to 0. So this is the auxiliary equation. So I am going to substitute when k is equal to 0.0625. Okay, I am going to substitute this value in this auxiliary equation. Then I am going to find out the values of s. After substituting this in this equation, I found s is equal to 0. So root locus is going to intersect at s is equal to 0. Okay, when k is equal to 0.625, the root locus is going to meet at 0. So that is the first value I got. Next, when k is equal to 0.125, I'm going to substitute this value in the auxiliary equation and I'm going to find out the roots. So after simplification, I got s is equal to plus or minus 0.66i. Okay, I'm substituting this value in this auxiliary equation and I'm going to find out the values of s. I hope you can simplify this. So this is equal to s is equal to plus or minus 0.66i. So this is when k is equal to 0.25. So the root locus is going to intersect at this point. So next is to find out the angle of arrival. Why it is arrival now? Because here we have a complex 0. So therefore we have to find out the angle of arrival, right? So we have a complex 0. Okay, so therefore we need to find out the angle of arrival. So now how to find out the angle of arrival? So we have formula. Okay, so now we have to find out the angle of arrival. That is, angle of arrival is equal to 180 minus summation of 5 zeros minus summation of 5 poles. So we need to find out 5 zeros as well as 5 poles. Okay, for this I'm going to draw this line like this. What are the roots we have? S is equal to 0 and S is equal to minus 1. Okay, so these are the two poles we have. Next, zeros. What are zeros we have? 2 plus 2i, right? We have 2 plus 2i, correct? 2 plus 2i, and the another one is 2 minus 2i. So what are these? These are the zeros. This is very much important. These two are poles and these two are zeros. Okay, so now I need to find out the angle of arrival. So first I am going to find out phi z. Okay, phi z. So first I am going to find out the angle of arrival for this point, that is 2 plus 2i. Apart from this, how many other zeros we have? So this is another 0 that I have. So therefore I am going to draw a line from here to here. Okay, like this. This is the only 0 that I have apart from this. What is the angle made by this with the horizontal axis? That is equal to 90. So therefore phi z is equal to 90. Okay, I hope it is clear. Now I need to find out phi p. Okay, how to find out phi p? So how many poles we have? We have 2 poles. That is, this S is equal to 0. I am going to draw a line from here. So this is a phi p1. Next, this is another pole I have. I am going to draw a line from here to here. This is a phi p2. Right? Okay. So phi p is equal to phi p1 plus phi p2. So I need to find phi p1 and phi p2. So what is this? S is equal to 0.5, right? So how to find out the phi p1? So phi p1 is equal to tan inverse of y by x. What is y? So this is the value. So from here to here it is 2. So from here to here, how much is this? 1.5, because from here to here it is 0.5. So from here to here it is 2. So if I subtract 2 minus 0.5, from this value to this value it is 1.5. So therefore y by x, 2 by 1.5, that is phi p1. Next, tan inverse of y by x for phi p2. See, from here to here, so from here to here it is 2 and it is 1. So this is equal to 3. From this point to this point it is 3. The height is 2. So therefore it will be, what is y? It is 2. What is x? It is 3. That is 2 by 3. So with the help of CANC, I can find out the tan inverse of this and this. So this I got 53.1 plus 33.69. 1.3, right? 53.13. Therefore, what is summation of poles is equal to 86, right? 86.82. So this is the summation of poles. These two are the poles. So I am going to find out the angle of arrival, that is equal to 180 minus summation of poles is how much? It is 90 minus of 86.82. Okay, so I arrive at angle of arrival is equal to 176.82. So this is the angle of arrival at this point. Okay, so what will be the phi a dash? So that is equal to minus 176.82. Okay, so that is for this point. angle of arrival will be minus 176.82 because these two are conjugates. Okay, after finding out the angle of arrival, the next step is to draw the root locus by combining the step number 1 to 7. Okay, so first I am going to locate the poles. So we have s is equal to 0.5. So this is a 0.5. Okay, in the same way s is equal to minus 1. So these are the two roots we have, poles. Next one is zeros. Okay, what are the roots of the zeros? That is, second, yeah, got it. So 2 plus 2i. So I am already marked the scales. So here I taken 1 unit as 2 centimeter. So it's a 2 plus 2i. So it's a 2i. So approximately it will come here. 2 minus 2i. So this is what here. This is 2 plus 2i. This one is 2 minus 2i. Okay. So this one is over. Next, we don't have asymptotes. We don't have centroid. So next thing that we need to find out is the intersection of we have a breakaway point. What is a breakaway point? It is minus 0.114. So minus 0.114 somewhere here. So this is a breakaway point. Breakaway, how much is this? So this is equal to minus 0.114. At this value the k is equal to 0.06. Okay, that is the breakaway point is over. Next is the intersection of root locus with the imaginary axis. So it is going to intersect at s is equal to 0 here. At this point k is equal to how much? Once again 0.625. Okay, k is equal to 0.0625. okay, pay attention, 625. Okay, next it is also going to intersect the imaginary axis at where, when k is equal to 0.125. It is going to intersect at 0.66 somewhere here. 0.66i and also minus 0.66i. Okay, next we have to draw the angle of arrival. What is the angle of arrival for 2 plus 2i? I got it as a positive 176.82. So with the help of protractor I am going to draw the first reference line. Reference line like this. For this, what is the angle of arrival? So from starting from 0, it is going to come at 176, right? 180, 170, 176 somewhere here. In the same way, I'm going to draw the line. So this is 176.82. In the same way, I supposed to draw for this angle of arrival 176 somewhere here. Okay. Okay. So this is what? Minus, right? Minus 176.8. Okay, now it's the time to draw the root locus. Okay, then how to draw this? As we know, the branches are going to start from roots, poles, right? So that is s is equal to 0.5 and s is equal to -1. So it is come towards the breakaway point. Where is the breakaway point? This is the breakaway point at -0.114. It will come towards the breakaway point like this. See here, the root locus is intersecting at 0 when k is equal to 0.06 something. Okay, after approaching to this point, it is going to break from here and is going to move towards the intersection of root locus with the imaginary axis. At this value, what is the value of k? So k value at this point is equal to 0.125, and here also k is equal to 0.125. Then it has to end to the zeros. So before ending to 0, it will follow this angle of arrival, and it is going to end like this. Here also it is going to follow the angle of arrival, and then it is going to end like this. As we know, the branches are going to start from poles. So we have two poles, that is 0.5 and -1, and it has to end to the here, that is 0, that is 2 plus 2i, 2 minus 2i. So this is the root locus. Now it is the time to write down the comment on stability. What is the comment of stability? See here. So when I start varying the value of k from 0 to infinity, so some portion of the root locus is to the right side and some to the left side. See, the system will be stable when the root locus is to the left side of the S-plane. What is that region? See, some from 0 to k, that is 0.06 something, the system is unstable. So therefore the stable region will be k. It is between 0.0625, that is less than this, and it should be greater than this value, and it should be less than 0.125. See, after 0.125, the system is going towards the unstable region. This is the stable region. Apart from this value, all the roots are lying to the right side of the S-plane, then the system is called as unstable. Okay, I hope you understood. Thank you. Namaste.